Hello everyone. So today we will see why sensors. Though you may know after going through all the previous videos exactly why we need the sensors. But again, to give you further clarity, we will see why sensors and what all these things sensors do. So sensors are essential component of many modern technologies including IoT, robotics, automation and smart devices and several reasons. So first thing sensor do is sensing the environment. Sensors allow the machines and devices to sense and respond to physical world around them. For example, temperature sensors can detect the changes in temperature, pressure sensors can detect the changes in pressure, motion sensors can detect the movement. So let's understand by the example. So consider you have a machine. Consider you have a machine. Some machine, let's say M, and it is heavy load machine. It operates for long hours. Let's say 12 hours, and it is a big and expensive machine. So it is possible due to some problem, overheat may occur. May occur inside the machine, and due to overheat, the machine can be damaged. So machine can be damaged. So using one simple temperature sensor with machine can avoid this. Okay. Now let's see the second point. Collecting data. Sensors can collect data about the environment or the states of a device. The data can be used to monitor performance, identify problems, and optimizing the processes. For an example, sensors in manufacturing plant collect the data about the production process, which can be used to identify areas for improvement and reduce downtime. Now let's see the third point, controlling process. Sensors can be used to control processes and make decisions based on data they collect. For an example, the temperature sensors can be used to control the temperature of room or pieces of equipment, or motion sensors can be used to trigger an alarm, turn on a light. So let's say you are making home security system. So in home security system, what you want, if someone get near to your windows or your door, let's say after 12 o'clock at night, then alarm should ring. So how is it possible? So we can simply place the motion sensors near the door and windows, and whenever anyone get under the proximity, the alarm will ring. Now let's understand the fourth point, enabling automation. Sensors are often used to enable automation in variety of industries, including manufacturing, healthcare, transportation. By using sensors to collect data and make decisions, machines and devices can operate it more efficiently and with less human intervention. Overall, sensors are critical for enabling machines and devices to interact with physical world, collect data and make decisions, and automate process leading to increase in efficiency, productivity and safety of variety of industries. So now we know why to use sensors. We saw so many advantage of sensors and so many applications. So now question is how to choose an sensor. So to choose right type of sensors or correct sensor, it depends upon various factors and this will vary project to project. So first thing you need to do is define the measurement. So start by defining the specific measurement that need to be made, such as temperature, pressure or humidity. Consider the range of values that need to be measured, as well as the specific characteristics of measurement that may affect sensor selection. So, okay, you may say, hey, we understood the first thing, that is, we need to define the measurement, and in measurement, we need to define which kind of environmental data we want to measure, like temperature, pressure, or humidity. Then, what is the second thing, range? So, let's take an example and understand. So, let's say you are making system simple environment monitoring system, EMS. So what this will do, this will consisting of the temperature sensor, because temperature is one of the environmental quantity. But in normal simple environment monitoring sensor systems, like for some room or for some open field, the temperature in generic scenario, consider you are in India, then it will vary from, let's say, 15 degrees Celsius to 45 degrees Celsius, or let's say higher end, 55 degrees Celsius. In India, generally range do not vary or always fall in between 15 to 55. It don't go below 15 and generally, and don't go below 55. But if you are making same sort of system for some other place, like let's say poles, south pole, where we have the researchers, and researchers want you to make the environment monitoring system so that they can monitor the environment. So here temperature will go will definitely go below 15 degrees. Here temperature even can go up to minus 10 degrees. So according to the environment data you are gonna measure, and according to the conditions we need to select the sensors. So you can't use the same sensors what you are using for Indian environment monitoring. You need to select the different sensor if you are making environment monitoring system for colder areas. So I hope you got this point. So now let's see the second point, consider the environment. So consider the environment in which the sensors will be used. So I guess I don't need to give the separate example, because in previous example only this point is also being covered, including temperature range, humidity, electromagnetic interference, and other environmental factors that may affect sensor performance. Choose a sensor that is designed to operate reliably in a specific environment where it will be used. Evaluate accuracy and precision. Evaluate the required accuracy and precision of measurement. Choose a sensor that can provide the required level of accuracy and precision while taking into account any cost constraints. So again, let's take an example. If you are making normal temperature sensors or normal environment monitoring system for your room, then it won't require very high precision and accuracy. If temperature vary zero point 0.5 degree, it will not matter much. But but if you are making environment monitoring system for some drugs manufacturer, where slightest of temperature change can affect the end product, here you will take the sensors with more precision and accuracy. Fourth point is consider power requirement. Consider the power requirements of sensors, including the voltage current needed to operate the sensor. Choose the sensors that can be powered using available power source, such as batteries or external power supplies. Evaluate communication requirement. Evaluate the communication requirements of sensors, including whether it need to provide analog or digital output signal, and whether it need to integrated with other devices or systems. Choose sensors that can provide the required output signal and can communicate with other devices as needed. And final point is consider cost. So consider the cost of sensor, including initial cost, any ongoing maintenance or replacement cost. Choose the sensors that provides the required level of performance at cost that fit within the available budget. By following these steps, you can choose a sensor that meets the specific requirements of your application while balancing performance, reliability, and cost. So now let's see some of the best practices. So first thing is calibrate your sensor. So whenever you procure a sensor or whenever you get this sensor, so it always comes with a default calibration. So though you are maybe not aware right now, in future in this course we will see how to calibrate your sensor. Okay, so we need to calibrate it, adjust it output levels, adjust it input level according to our project requirement. Second point is choose right sensor for the job. Select the sensor that is designed for specific measurement needed and that can operate reliably in the environment in which it will be used. Consider factors such as accuracy, precision, and power requirements when selecting the sensor. So, of course, it shouldn't be like, okay, this thing also can work, so I will use it. No, you should choose the correct sensor for a specific job. Install sensor properly. Install sensors in the correct location and orientation to ensure they can accurately measure the desired parameter. Take care to avoid interference from other devices or materials that may affect sensor performance. Protect these sensors from damage. Sensors should be protected from physical damage, moisture, and external temperature, which can affect sensors' performance. Choose suitable housing to enclose enclosure to protect the sensor from environment in which they will be used. Again, let me give you one example. So consider you are deploying your sensor in outside field. So there is no protection. Then in outside field it may rain, and if it rain it will destroy the sensor circuit. Short circuit may occur and sensors will be damaged. So in this kind of scenario we must provide proper protection by giving proper packaging and housing. Fifth point is test sensors regularly. Test sensors regularly to ensure that they are still providing accurate and consistent measurements. This can involve comparing the sensor's output to known standard or simply observing the output over time to detect any drift or inconsistency. Sixth and final point is use sensor data effectively. Use sensor data that make informed decisions and optimize system performance. Consider using analytics and machine learning algorithms to extract insight from sensors data and use the insight to improve system performance or detect anomalies. So, by following these best practices, you can ensure that the sensors provide accurate and reliable measurements and that sensor data is used effectively in optimize system performance and improve decision making. So that's it for this video. See you in the next video. Till then, bye.